here with Sustainable Milton to explore one of the most energy efficient building standards in the world, the Passive House. Passive houses are a rigorous building standard with ultra-low energy consumption to maintain a comfortable indoor climate without your traditional heating and cooling systems. Passive houses reduce energy consumption, lower utility costs, and provide a comfortable indoor temperature level while minimizing environmental impacts. Now today we're going to focus on the 5 core principles that make up any passive house, see them in action, and finish by looking at why investing in a passive house design is beneficial over time. The 5 core principles involve a super insulated envelope, thermal bridge-free construction, airtight construction, heat recovery ventilation, and high performance windows. Now let's get started! Everything starts with insulation. Instead of simply meeting minimum building code requirements, passive houses surround the entire building with a continuous, highly insulated envelope. Here in Milton, Rockwool provides great stone wool insulation. It maintains its shape over time, allows water vapor to pass through while resisting moisture damage, and provides long-term fire safety. A well-insulated building keeps warmth inside during winter, blocks unwanted heat during summer, and dramatically reduces the need for heating and cooling. Heat naturally follows the easiest path. A thermal bridge is any location where heat bypasses insulation and escapes through the structure. There are 3 common types of thermal bridges: repeated, such as wood or steel studs; linear, where different building components meet, like windows connecting to walls; and point, created by fasteners or insulation attachments. Passive house construction carefully designs these connections to minimize heat loss. Reducing thermal bridges or transitioning most of them to point thermal bridges improves comfort, prevents condensation, and increases the durability of the building envelope. In addition to reducing thermal bridges, carefully sealing the house to create an airtight enclosure also helps prevent energy loss and moisture accumulation inside the walls. Builders verify the airtightness using a blower door test, which measures how much air escapes under pressure. Reducing air leaks eliminates cold drafts, prevents condensation, protects building materials, and significantly improves energy efficiency. Since passive houses are extremely airtight, fresh air is supplied mechanically rather than through uncontrolled leaks. This is where heat recovery ventilation comes in. The system continuously removes stale indoor air while bringing in fresh outdoor air. Before the warm indoor air leaves the building, most of its heat is transferred to the incoming fresh air. This keeps the home comfortable while greatly reducing heating demand. The system also helps manage humidity and maintains excellent indoor air quality. Since these systems circulate air so efficiently, it's recommended to use recirculating range hoods when cooking to reduce the chance of smoke alarms being triggered. Lastly, windows can heavily impact the general temperature of the house and the energy required to maintain it. Rather than standard double glazing, passive houses typically use triple pane, high-performance glazing with insulated frames. The measurement of thermal resistance in construction, also known as the R value, differs greatly between regular and passive windows. The R value for regular windows is often around 3, whereas the score for passive ones is around 7. Especially since windows are the weakest point for thermal loss, the considerably higher R value demonstrates how these windows reduce heat loss. That being said, it still allows beneficial sunlight into the house. Designers carefully calculate the window-to-wall ratio based on building orientation, glazing type, and exterior shading to maximize passive solar heating in the winter while reducing overheating during the summer. Many passive houses also incorporate advanced glazing technologies that improve thermal insulation, reduce outside noise, enhance daylight, improve fire safety, and even offer self-cleaning options. A common misconception about passive houses is that they're completely focused on energy. In reality, they're also about choosing durable, sustainable materials. Natural materials like lime plaster, clay finishes, engineered timber, cork, mineral-based paints, and natural wool insulation help regulate indoor humidity, improve indoor air quality, reduce embodied carbon, and create comfortable living spaces. Other sustainable features may include Pilkington glass, which has various uses, bio-based spray foam insulation, solar energy systems, and water-conserving plumbing fixtures. These materials are great for appearance, but also for moisture performance, durability, thermal stability, air tightness compatibility, and low emissions. Cost-wise, passive houses are generally a bit more expensive to build because of better insulation, windows, and construction detailing. However, those costs are offset by dramatically lower heating and cooling bills, reduced maintenance, increased durability, and improved comfort. Nonetheless, taller buildings are more cost-effective because the surface area to volume ratio means that less insulation is required, and it's easier to meet the air sealing requirements. In many projects, the additional investment can be covered within a few years through reduced operating costs. Over the lifetime of the building, homeowners continue saving energy while enjoying healthier indoor environments. Ultimately, passive houses aren't about sacrificing comfort. They're about designing better from the very beginning. By combining a super insulated envelope, thermal bridge-free construction, airtight construction, heat recovery ventilation, and high-performance windows, these buildings use far less energy to support a sustainable and comfortable future. Thanks for watching!